Hello, welcome to this lecture 4 of this course on modeling, analysis and estimation of three-phase unbalanced power network. In the last lecture, we have started into looking into the structure of the three-phase transmission line. So, what we have said that we have got a three-phase transmission line, phase A, phase B, phase C, and we are also now trying to calculate the inductance of this three-phase transmission line in the presence of the ground. And as we said that when we are considering the ground, we are essentially considering the effect of the ground by considering a fictitious Carson's line. And then in that lecture we have shown all the distances, and then we have also defined all the primitive impedances, both self as well as the mutual. And then after that we have also written down the individual voltage equations for all the phases A, B, C as well as the fictitious conductor D. So, for our reference, we will start with the individual equations, essentially the individual voltage equations. We are not going to draw that diagram again because it will unnecessarily take time. So, we will simply start with the individual voltage equation. So, what we are discussing is that three phase transmission lines. So, three phase, basically we are calculating inductance of three phase transmission line. And we have written 4 voltage equations, VA minus VA dash. We are just writing it for quick reference. Otherwise, ZAA, all are primitive, ZAA IA plus ZAB IB plus ZAC IC plus ZAD ID. Of course, this is primitive. We then VB minus VB dash is equal to ZBA means ZAB IA plus ZBB IB plus ZBC IC plus ZBD ID. And then we have VC minus VC dash is equal to ZCA, right, is equal to, that is ZAC. I can write down that ZAC IA. Then we write ZCBIB, but then again ZCB is equal to ZBC. So, then therefore, I can write it down as ZBC IB plus ZCC IC plus ZCD ID. And then of course, VD minus VD dash is equal to ZDA, that is equal to ZAD IA plus ZDB, that is equal to ZBD. Please note all these quantities, all these variables have been defined in the last lecture. So, then ZDC, that is equal to ZCD. So, ZCD IC, it is here, plus ZDD ID. It will be, this bar will not be here. So, all these are primitive and we have already defined them. So, let us give them some equation numbers. So, this is equation 1, 2, 3 and 4. Now, if you do recall from the diagram what we have already shown in the last lecture, we have shown that D point is actually connected to the local ground. So, then therefore, VD is equal to 0. We are taking that is to be the reference. we have also shown that the point A dash, B dash, C dash as well as D dash, they are all connected to the remote ground. So, then therefore, all these points V A dash and V D dash, they are at the same potential. So, I can say that V A dash minus V D dash is equal to 0, V B dash minus, sorry, no, this is not the correct way of writing. These are all wrong way of writing. Notations are little wrong here, so I should correct all these notations. So, this is V A dash here, V B dash here, V C dash here, V D dash here. So, dash is after the points A dash, A, B, C and D. And we have seen that V D is equal to 0 and V A dash minus V D dash is also 0, and V B dash minus V D dash is also equal to 0, and V C dash minus V D dash also equal to 0, because all these 4 points are connected to the remote ground. So, then therefore, we have got this, and we have also seen that we have I D is equal to minus of I A plus I B plus I C. So, we will use these relations here. Now, what I do is, I now do 1 minus 4. I simply subtract fourth equation from the first equation. So, what do I get? I get V A minus V A dash minus V D plus V D dash is equal to Z A minus Z A D into I A plus Z A B minus Z B D into I B plus Z A C minus Z C D into I C plus Z A D minus Z D D into I D. Now, here in this equation V D is 0. So, then I can write it down that V A minus V A dash minus V D dash, correct. So, that is equal to, I can write it down at Z A A. Here we have put that V D is equal to 0. Z A A, sorry, this is all primitive. Z A D I A plus Z A B minus Z B D into I B, all are primitive, plus Z A C minus Z C D into I C. And now we will substitute the expression of I D in terms of I A, I B and I C. So, it will be minus Z A D minus Z D D into I A plus I B plus I C. Now, if we look at the left hand side, we know that V A dash minus V D dash is equal to 0. So, then therefore, this left hand side becomes V A, and the right hand side, what we can do is that from here to here I can take I A common, from here to here I can take I B common, and from here to here I can take I C common. So, let us do that. So then therefore, ZAA minus ZAD minus ZAD plus ZDD. Okay. So it would be VA ZAA minus 2ZAD plus ZDD into IA ZAB minus ZBD minus ZAD plus ZDD. AB minus BD minus ZAD minus Z plus ZDD plus ZAB minus ZBD AD DD. BD minus ZAD plus ZDD. This is IB plus AC minus CD minus AD plus DD. So ZAC minus ZCD minus ZAD plus ZDD. IC. All are primitive. Right? So what we call is now, we call this as ZAA without a bar. We call this as ZAB. We call this as ZAC. So then therefore, this equation now becomes ZAA into IA plus ZAB into IB plus ZAC into IC. This is BA. Right? Where ZA is this, ZAB is this, and ZAC is this. So we have already defined it, so we are not writing it. Now by 2 minus 4, if I do the same operation with second equation, so what do I get? VB minus VB dash minus VD plus VD dash, and we have already seen that finally that would be equal to ZAB minus ZAD. So it would be ZAB minus ZAD, ZAB minus ZAD into IA plus ZBB minus ZBD, ZBB minus ZBD into IB, all are primitive, plus ZBC minus ZCD, ZBC minus ZCD into IC plus ZBD minus ZDD, ZBD minus ZDD into ID. So again as usual, so I can write it is that VB minus VD is 0, so minus VB dash minus VD dash is equal to ZAB minus ZAD into IA plus ZBB minus ZBD into IB plus ZBC minus ZCD into IC and minus, sorry, these are all primitive, ZBD minus ZDD IA plus IB plus IC. Now this is 0, so then therefore I can write down that VB is equal to ZAB minus ZAD minus ZBD plus ZDD into IA plus ZBB, all are primitive, minus ZBD, then minus, so it would be basically ZBB minus ZBD minus ZBD plus, so it would be 2. Let me write it down more neatly. 2 ZBD, 2 ZBD plus ZDD into IB, all are primitive, plus ZBC minus ZCD minus ZBD plus ZDD into IC. So again we call this as ZBA without any bar. We call this as ZBB. We call this as ZBC. So then therefore VB becomes now ZBA into IA plus ZBB into IB plus ZBC into IC. Now we have considered up to 4 equations, so that means it would be equation number 5, it would be equation number 6. Now look at the expression of ZAB and ZBA. What is ZAB? ZAB minus ZBD minus ZAD plus ZDD. And what is the expression of ZBA? Identically same, ZAB minus ZBD minus ZAD plus ZDD, right. So therefore we can here see that ZAB is equal to ZBA. So that is our first observation, correct. Now let us do by 3 minus 4. So if I do 3 minus 4, so what do I get? So by 3 minus 4. So VC minus VC dash minus VD plus VD dash is equal to ZAC minus ZAD, ZAC minus ZAD into IA plus ZBC minus ZBD, ZBC minus ZBD into IB plus ZCC minus ZCD, ZCC minus ZCD into IC plus ZCD minus ZDD, ZCD minus ZDD into ID. All are primitive. Right? So it becomes VC minus VC dash minus VD dash is equal to ZAC minus ZAD IA plus ZBC minus ZBD into IB plus ZCC minus ZCD into IC minus ZCD minus ZDD into IA plus IB plus IC. So therefore, VC becomes equal to ZAC, all are primitive, minus ZAD minus ZCD plus ZDD into IA plus ZBC minus ZBD minus ZCD plus ZDD into IB plus ZCC minus 2ZCD plus ZDD into IC. Now we again call this, ZCA without any bar, we call this ZCB, we call this ZCC. So then therefore my VC becomes now ZCA into IA plus ZCB into IB plus ZCC into IC. So this is equation number 7, right? Now if I look into the expression of say ZCA, what is the expression of ZCA? ZCA is ZAC minus ZAD minus ZCD plus ZDD. Let us look into the expression of ZAC. ZAC is also exactly the ZAC minus ZCD minus ZAD plus ZDD, right. So then therefore, here also I can write down that ZAC is equal to ZCA, and we have already shown that ZAB is equal to ZBA. Similarly, I can show identically same, please cross check, that ZBC is equal to ZCB, right. Now if I write equation number 5, 6 and 7 together, right, from equations 5, 6, 7, I can write down that VA, VB, VC is equal to ZAA, ZAB, ZAC, ZBA, ZBB, ZBC, ZCA, ZCB, ZCC, IA, IB, IC. Now, because ZAB is equal to ZBA, ZAC is equal to ZCA and ZBC is equal to ZCB, so that means this is a clear cut symmetric matrix. Right. So, then therefore, what happens is that this three phase line with in the presence of ground can be represented by a simple voltage current relation, where these voltages are given by a vector VA, VB, VC, and the three phase currents are given by a vector IA, IB, IC, and the relation between V vector and the Z and also the I vector is given by a Z matrix, impedance matrix, and that matrix is a symmetric matrix. So, then therefore, I can write it down it as vector V is equal to matrix Z into I, correct. So, then therefore, I can say that for this line I can say that V is equal to a three phase line. V is VA, VB, VC transpose. So, it is a 3 cross 1 vector. I vector is IA, IB, IC transpose, and Z matrices ZA, ZAB, ZAC, ZBA is equal to ZAB. So, ZAB, ZBB, and ZBC, and ZC is equal to ZAC. So, ZAC, ZCB is equal to ZBC, it is ZBC and ZCC. So, this is a symmetric impedance matrix, and all the values of these elements of this symmetric impedance matrix are given by the are actually given in terms of this primitive impedances, correct. So, then therefore, in the next lecture we will see that what would be the values of all these elements in terms of the actual line dimensions, right. So, that part we will actually take on in the next lecture. Thank you.